a demo of intelligent Anycast server selection using segment routing and in-band OAM. Multiple instances of highly redundant microservices, such as video caches, are hosted in public cloud and are accessible over Anycast IPv6 addresses. When a user tries to access the service, based on Anycast routing, one of the many servers gets selected. This often leads to timeouts and suboptimal user experience. To enhance the user experience accessing the Anycast service, we introduce intelligent server selection that takes into consideration network and application server state at the instance the service is accessed. For this purpose, an entity called M-Anycast server is introduced. This entity attracts Anycast connection requests, replicates the connection request towards multiple of the available Anycast servers, and it steers the traffic towards these Anycast servers using segment routing. It evaluates multiple responses that are received and picks the best one at any moment and sends it towards the client. From then on, client uses segment routing, information that is gleaned in the connection request response, and directs the packets directly towards the selected server. This is our demo topology in Viral. Each of the boxes here is a Ubuntu VM with VPP installed for packet processing. For the purpose of the demo, the Anycast service is an Nginx web server hosted on all these three servers, which serves a web page. The client which accesses this Anycast web page over a v6 address is located in this VM with VPP0 instance co-located. And this is our M-Anycast server. As you see, each of the servers is connected to this network over two links, and asymmetric routing is set up such that packets from this network towards the server traverses one path, and packets from server towards this network takes the other link. This is so that we can simulate round trip and one-way delay from the server and see how varying the delay, which reflects the current network conditions, influences the server selection. This is the console of M-Anycast server, and this is its current configuration. It is configured to do server selection based on one-way delay from the server towards the client. And this is the Anycast prefix for which an SR multicast policy is set up so that the packets are replicated and evaluated over server 1, server 2 and server 3. And this is a console of VPP0 which is connected to the client that accesses the Anycast service. And it is configured to route the Anycast packets towards the Anycast prefix to M-Anycast server. And here's an example of one of the services from this prefix, which is also going to the M-Anycast server at the moment. Now let's go ahead and access the service. So server 1 responded, and let's see what happens to the fib entry here. We see that the routing rule towards M-Anycast server for the prefix has been modified to go over a dynamically constructed SR tunnel. Whose destination is server 1. Now if we try again, any one of the 3 servers are picked, and this is because currently all the links are symmetrical, they have similar delays. Now let's simulate a network condition such that the relay from server 1 towards the client is higher. So I've introduced a 500 millisecond delay on the link from server 1 towards this network, towards the client network. Let's go back to the client console and see what happens. So now this, instead of server 1, either server 2 or 3 are selected because the one-way delay from 1 is higher than 2 and 3. Let's take a look at what happened by looking at the captures at client as well as on the M-Anycast server. Here the client tried to send a SYN packet towards the Anycast service. This did not contain any hop-by-hop or SR header. Now this packet was replicated on the M-Anycast server towards server 1, 2 and 3 along with in-band OAM and SR header insertion. Only one of the responses is sent out towards the client, which contains the SR header to signal the server that was selected. In this case, server 2 was selected, and hence you see that ACK and rest of the packet data exchange happens directly with the selected server, which is server 2 here, and the actual Anycast address is embedded in the routing header, in the SR header. That concludes the demo. Thank you.